welcome to the Autotronics course. So we are in our 12th week. So we are discussing this automotive system diagnostics, and in fact we had earlier we had discussed some of the overall generic flowcharts as well as like generic templates where when you try to troubleshoot a certain systems, how these troubleshootings or diagnostics are done with reference to a commercial angle or with reference to a conventional perspective point of view, or on a kind of a professional note. Okay, and then we also had some discussion about the symptoms and the possible fault diagnostics, which might be useful. Then as far as this diagnostics is concerned, with the recent development, there is more interaction of sensors, intervention of sensors in the complete system. So these sensors acts as a kind of a pathway for diagnosing the complete system. So IoT integrated sensors or network integrated sensors will be helpful, highly helpful for us to have a diagnostics. Like even recently, if you have seen some of the vehicles, there is a kind of an app which is installed in your mobile, and this app will be helpful for you to interface with the the vehicle, so that you can constantly monitor the behavior, and then you can constantly do the diagnostics of the vehicle. And in fact, even if there is any kind of deviations are there, or if there is any issues are there, that can be easily monitored. Now, so we had discussed in the last class about the data quotient, the signal conditioning, the different types of communication networks in the modern vehicle systems, and then some of the key components. And then we also had a discussion about the sensor system architecture, about the different types of sensor system architecture, and how these sensor system architectures are designed for the automotive related applications. Okay. Now, in this lecture, we will discuss about an intermittent fault. So as far as when you try to talk about fault, so the fault can be classified into two. One we call it as an intermittent fault, and another one is we call it as a permanent fault. So as far as these intermittent faults are concerned, they are sporadic and unpredictable, challenging to diagnose. Whereas permanent faults are concerned, they are consistently present and it is easier to diagnose. So an intermittent fault refers to a malfunction in electronic or mechanical system that occurs at irregular periods. So these defects emerges and disappears in unpredictable ways, frequently eluding normal testing and diagnostic procedures. So unlike permanent problems which are always present, intermittent faults can only occur under certain operating conditions, making them infamously difficult to identify and resolve. So importance in modern automotive system, these modern vehicles use a complex network of electronic control units, sensors and actuators because of the increasing complexity and interconnection of the system. Even a minor glitch such as a bad electrical connection, a power surge or a data bus error can cause intermittent failures. Such defects are major cause of no fault found events, warrant period and unpredictable vehicle behaviors. Why intermittent fault diagnostics matters? First is with reference to reliability and safety. These intermittent faults can compromise the vehicle safety's critical systems, you have a kind of an ABS or an airbag deployment, and then there are some engine controls are there, without leaving a persistent evidence or posting a kind of a latent risk. Next, with reference to cost and efficiency perspective point of view, they rapidly increase the diagnostic time, parts replacement cost and workshop downtime, as technician may replace fault-free component in pursuit of elusive problems. Next, with reference to technical challenge perspective point of view, these sporadic symptoms demand advanced diagnostic technique combining hardware, high-speed data logging, protocol analyzer and software, including the intelligent logging, machine learning for pattern recognitions. Now, when you try to look into the categories of these root causes, so these root causes can be categorized under three different categories. So one category is with reference to physical and electrical connection issues, where there are loose connectors are there, vibration induced micro movements, and incomplete lock-in can cause connectors to make or break contact intermittently. cracked solder joints, cyclic thermal stresses, and vibration cause micro cracks at solder connection in the ECUs, leading to a transient circuit breaks. Oxidation and corrosion, like environmental exposure, leads to oxidation of connector pins, increasing resistance and susceptibility to intermittent contact loss. Next, when we try to talk about wiring harness and cable problems, insulating degradations, thermal, chemical or mechanical damages to wire insulation may induce random short circuits, especially in high vibration areas. Now, when we try to talk about conductors, they are microfracture, especially the conductor based microfracture, where there is a continuous fluxing or strain from engine and chassis movement can cause fractures not visible to the naked eye, resulting in sporadic open and shorts. Then we have a harness chafing, where an abrasion against a chassis components can wear through the wiring, producing a kind of a momentary fault as the wires shift with the vehicle motion. Next, we have the environmental and mechanical factors, which is a kind of a thermal cycling, where automotive electronic regularly experience wide temperature swings, causing material to expand and contract at different rates, disrupting connections or contact pressure unpredictably. Next is with reference to moisture ingressness, where seepage into connectors, sensors housing or ECU facilities corrosions creates conductive path for brief short circuit or cause condensation shorts. Next, we have a mechanical vibration, where it's a kind of a road induced vibration and shocks, especially in harsh environments, can trigger fault in connectors with marginal fit or sensors which are inadequately anchored. Now, when we try to look into the category 2 of root cause, this is with reference to electrical and electromagnetic disturbances. This is a kind of EMI, which is a kind of recent like issues which is being addressed by several industries. So this electromagnetic interference, it has an external radio frequency source or internal switching operation, generate noise glitches that momentarily disrupt sensor signals or digital communication lines. Then when we try to talk about power line, it has a transient voltage, power line transient. Then there is a voltage spikes, dips and ripples from alternator, battery or actuator load changes. Intermittently alter the operational characteristics of analog or digital circuitry. Next, we have a component aging and degradation, where there is a dielectric aging is there. Capacitors or insulating materials degrade over time, changing their electrical properties and increasing the likelihood of brief failures. We have the semiconductor wear out, which is a kind of a repeated thermal or electrical stress can provoke the intermittent leakage, latch up or timing errors in integrated circuits, particularly in analog front ends or analog to digital converters. With reference to software and protocol related faults, timing anomalies where asynchronous operation or glitches in real-time operation system, which we call it as RTOs. Managing the sensor or actuator data results in a missed or misinterpretation events. We have the protocol errors, which is a kind of a sporadic network bus attribution conflict or rare race conditions in firmware can momentarily prevent correct message and transmission or reception in the system. Now, if you look into this particular process, you may ask me a question, why this fault matters? Because one thing which matters us is the diagnostic complexity, that is a transient irreproducible behavior complicate the root cause analysis, leading to high rates, no fault found during the service. Safety risk, momentary loss of function in critical subsystems, steering, braking, airbags can create hazardous situations without leaving persistent evidence. Cost and downtime, Repetitive visits and unnecessary part replacement drive up warranty cost and reduce customer satisfaction. Precursor to permanent failure, which is frequently intermittent faults, precede a catastrophic irreversible component failure, which is also observed. Some of the key challenges in diagnosing the intermittent fault includes the sporadic and unpredictable occurrence, where the intermittent faults happens at an irregular, unpredictable time, often without any kind of a clear pattern, because they may not appear during the diagnostic test or inspection. Technician face a significant difficult in observing or reproducing the fault behavior. This unpredictable cause delay in fault detection and complicates the troubleshooting efforts. Now, when we look into the transient nature and elusiveness, these faults often disappear spontaneously, leaving no permanent evidence or error logs. Traditional diagnostic tools which rely on continuous or steady state fault signals may fail to capture momentary glitches that last milliseconds or less. This leads to frequent no fault found conditions, which we call it as NFF, outcomes where no malfunction can be reproduced despite reported symptoms. Next, we have the misleading diagnostic codes, which we call it as diagnostic trouble codes, which is generated during an intermittent fault, which may be generic, ambiguous, or uninformative. Faults in one system may manifest as errors in multiple subsystems due to interconnected vehicle electronics, confusing root cause identification. Multiple modes may log errors separately, making it hard to pinpoint the origin. The challenges in diagnosing the intermittent fault is the one which we will be discussing now, where, like, if you look into the overall challenges of it, there are multiple possible root causes are there. Like in the case of a multiple possible root cause, these intermittent faults may arise from various sources, including wiring, connectors, ECUs, power supply, software, or even environmental conditions. This multifractional nature demands comprehensive systems level diagnosis rather than isolated component checks, requiring sophisticated diagnostic strategies. Now, when we look into the limitation of this diagnostic tool and techniques, conventional onboard diagnostics and static scan tools may lack the speed or resolution to detect brief or rare fault events. Now, we also have manual inspection techniques are often ineffective against microscopic faults such as micro cracks or oxidation points that only cause this momentary disruption. Lack of continuous high-speed monitoring system reduces the chance of capturing the fault events for analysis. Similarly, when you try to take a data overload and the interpretation complexity, high-frequency data logging to catch momentary fault generated large volumes of data that required advanced processing and analysis. Differentiating true intermittent faults from noise or harmless transient signals demand a sophisticated algorithm and signal processing techniques such as machine learning or statistical pattern recognition. Some of the challenges in the diagnosing intermittent faults includes the environmental and operational variability. So many intermittent faults depends on specific environmental or operational conditions such as temperature, vibration, humidity, or load. The faults may only manifest in certain combinations of these factors, complicating testing and fault replication in workshop settings. Similarly, when we look into the safety and reliability concerns, because intermittent faults can affect safety critical systems erratically, they pose a latent risk if undetected. Ensuring the vehicle safety demands and rigorous diagnostic methods that can identify and isolate such faults before they lead to the failure. Now, let us discuss about the different advanced diagnostic approaches for intermittent fault. One is called as a data-driven diagnostics method. Another one we call it as a model-based diagnostic approach. We have a carrier signal and a spectral analysis method, a high speed and a parallel monitoring hardware, integrated with vehicle communication networks, software tools and predictive analytics. Now, first let us discuss about the data-driven diagnostics method. So, these methods leverage historical and real-time data from sensors and electronic control units to find the pattern suggestive of intermittent failures. So, one of the key example includes the machine learning ML and the artificial intelligence AI. It basically supports a kind of a vector machine, which we call it as SVM. Then we have a kind of a random forest and a deep learning models are used to assess the large data sets of sensors and actuator signals. They can be categorized normal and abnormal behavior by finding minute statistical anomalies inside the high frequency data streams. Next, we have the entropy based feature extraction. As far as these entropy based feature extraction is concerned, as the name suggests, a fuzzy entropy and a multiscale entropy matrix estimates the complexity and irregularity of the sensor inputs, which aids in differentiating normal behavior from fault induced fluctuations. It has efficient at detecting the nonlinear, non-stationary characteristics of intermittent faults. Then we have the statistical and trend analysis. These statistical metrics means a variance and kurtosis, monitor deviation in sensors and actuator signals across time. So, some of the trend analysis can identify impending failures based on the early signals of these signal fluctuations. So, overall, these are the three different categories which are under the data driven based diagnostic method. Next method is called as the model based diagnostic approach. These methods incorporates mathematical or analytical model representing the expected behavior of the system for fault detection. Here we have an analytical redundancy, that is, it uses a mathematical model or observer to estimate the sensor output based on other sensor inputs or the system states. When we look into the discrepancies perspective point of view, the discrepancies between the estimated and the actual signal indicate a kind of a potential fault in the system. Similarly, when we look into the observer and Kalmar filter technique, the observers can track system states and filter out noise, allowing for the detection of the abnormalities caused by the intermittent faults. So, some of the aspects of these observers are like, it's a kind of an extended Kalman filter, we call it as EKF, can handle a nonlinear system common in vehicle dynamics and sensor system. Then we have a sensor identification and residual generation. The process of creating a model that approximates the system behavior and generating residuals, the differences between measured and the predicted values to identify the faults. So, these are some of the model based diagnostic approach which exhibits. Then we have a carrier signal and a spectral analysis method. These techniques enhance fault detection sensitivity by transforming the signal for finer analysis, which includes a carrier signal injection. A known fixed frequency signal is superimposed on the sensor wiring or signals to monitor the system integrity. Any interruption or distortion in the carrier indicates the connection or the wiring faults. Similarly, we have a frequency domain and spectral methods. It's a kind of a fast Fourier transform, the wavelet transform and other spectral analysis which identify the transient anomalies and intermittent faults by the revealing signals. Frequency components, noise or glitches not readily visible in the time domain can be easily analyzed using this frequency domain as well as in the spectral modes. Now we have the time frequency analysis. So as far as these time frequency analysis are concerned, there are techniques such as short time Fourier transform, which we call it as STFT, and continuous wavelet Fourier transform, which we call it as CWT, provide localized frequency content and changes associated with the transient faults. So when you look into the high speed and parallel monitoring hardware, so again it is classified under three different subsets, which comes under the category of high speed and parallel monitoring hardware. One is a kind of a dedicated intermittent fault detectors, which we call it as IFDs. A specialized hardware continuously monitors multiple sensor channels simultaneously at high sampling rates, capturing transient fault events that standard DAC system might miss. Second, with reference to event trigger data logging is concerned, only signals associated with direct anomalies are recorded, optimizing memory and analysis of efficiency. Then we have a kind of a time-stamped signal acquisition, which enables a correlation of the fault event with the vehicle operation parameter to locate the kind of a fault condition what we are looking for. Now let us discuss about the integration with the vehicle communication networks. So if you closely observe the overall characteristics of this vehicle communication network, we can classify these vehicle communication network into two. One is called as a network traffic analysis. Another one we call it as a gateway and a protocol diagnostic system. In the case of a network traffic analysis, we have a monitoring, then we have the monitoring CAN, LIN and a flex rate and a Ethernet traffic for anomalies such as corrupted, delayed or missing message, which helps detect intermittent communication faults affecting the sensor data transmission. Similarly, when we look into the gateway and the protocol level diagnostics, we have a gateways analyze data flows between domains and zones, pinpointing where intermittents are there. There is a kind of fault disrupt communications are there. These are well handled under these kind of integration with vehicle communications network. The next is the software and tool predict analysis. As far as these software and tool predict analysis is concerned, we can classify the software and tool predict analysis with two subsystems. One is a diagnostic trouble code, which we call it as a DTC analytic. It has an advanced log analytic process, stored DTCs and freeze frame data to derive patterns linked to the intermittent fault. Similarly, we have a predictive maintenance algorithm which uses a kind of a historical fault and sensor data to predict when components may fail, enabling a proactive remedies before the permanent fault occurs. So these are the two different subcategories which are contributing towards the software tool and the predictive analytics. Now let us discuss about the architecture of an intermittent fault diagnostic system. An intermittent fault diagnostic system in autotronics detects, records and analyzes transitory and unpredictable defects that cause intermittent disruption to vehicle electronics or sensor systems. Such a system architecture combines specialized hardware for high speed parallel signal monitoring with sophisticated software for real-time analysis, fault isolation and communication integration across the vehicle network. So we have a front-end signal acquisition and condition where gathering and preparing and initial signals are deployed. Then we have a high-speed data and acquisition hardware capturing the data quickly and efficiently. Then we have a digital signal processing and feature extraction where analyzing and extracting key features. Then we have a fault isolation and diagnostic logics, with the main functionality of this fault isolation and diagnostic logics is to identify and diagnosing the fault. Next is the one of the communication system is to integrate with the vehicle. So the integration with vehicle communication system, that is connecting with the vehicle communication network. And the next one is a kind of a user interface and a data visualization, which is mainly meant for presenting data in a user friendly format. And the last one is a kind of a system level feature and design consideration, which is useful for incorporating the overall system design aspects.